Hello, everyone. This is Brian Cutler. Once again, I'm a system engineer and I work for Rovisys. And I graduated from NC State in the May of 2019 and studied chemical engineering. And on Friday, October 23rd, I'll be giving a guest lecture for the process controls class. And I'm making a series of videos to show how to make a pretty basic class example on a process control system and all the aspects involved in it. So in the first video, we showed you guys how to set up the controller program along with set up a virtual controller for it. The second video, I showed you guys how to set up the control modules associated with the system. And this third and final video, I'm going to show you guys how all that stuff works together to create one of these process control loops that you guys have been learning all the mathematics for and whatnot. So just to get us all acquainted again, I'll show you guys the example that I base this off of. So we got a temperature transmitter here. It's getting fed into a temperature controller, and it's controlling the steam control valve, which controls how much steam is going into this heat exchanger. So what I did with the control modules we made in the last video, I went ahead and made a basic sim logic routine. So I'll just kind of walk through what each of these rungs are doing within this routine. So this first rung here is that it sets all the relevant control models to simulation mode and to program mode. So we're setting the temperature probe along with the control valve into sim mode. We're enabling the control loop, and we're acquiring the control valve so we can issue commands to it. And then we're issuing a one-shot, which means that once this value is true, these are all constantly being evaluated. However, these one-shots only get evaluated the first time this value is true. So it does these action once and then stops up until this gets reset. So as soon as we enable this start sim bit, we'll be setting the temperature transmitter value to 25, and we'll be setting the temperature controller into auto mode, and we'll be acquiring the temperature controller as well. That's just pretty much the programmer, that the controller program saying, hey, temperature control loop, we're gonna be issuing commands to you. So that's kind of setting all of our control models for us to be able to do the sim. And then this rung down here, this is setting the program set point for that temperature control. So we're going to be starting our temperature at 25 degrees Celsius, and we're going to be trying to hit 80 degrees Celsius. And then this is just some basic sim logic that if the control valve is over 25% open, it increments the temperature simulated value just by this function here. So it's just a way to act like as you open the more steam to the system, the temperature is going to increase. However, here I set it up so that if the control valve is below 25% open, then it will subtract the temperature value over here. That's just to kind of simulate the actual process itself. And this rung down here is just kind of a fail-safe that so we don't go above our upper limit of our engineering units of 100 degrees Celsius. So let's go ahead and get this party started by starting this sim. So I'll just go ahead and start this here, and then we'll go take a look at the temperature controller to see what's going on here. So you see we got the temperature value over here, and we have the output control value, which is the steam control valve position, at least the commanded valve position. And as you can see, early in the game it's 100% open, but then as we approach our set point of 80 degrees Celsius, it's starting to close up some. So it's saying, hey, like I'm getting close to my set point, we should probably take it a little easy. And obviously with how we set up our sim logic, with it being a linear function, it isn't quite impacting this. It's just kind of a discrete point. Once it hits 25%, it starts to decrease. So once again, this isn't the best representation of how these systems work, but It's good enough for government work. So yeah, so as you can see now, we're not at our set point of 80 degrees Celsius, but we're at the point now where it's gonna kind of probably just bounce up and forth. I think that's some offset of about 5 degrees Celsius based on this control system. So there's two big factors at play with that creates this offset. Our sim logic is imperfect. It doesn't represent actually how the amount of steam is impacting the temperature, so that's at play. And second it off, we would definitely have to play around with our gain and our different derivative, integral, and proportional gain control. So all those factors are at play, but it actually seems like we actually are hovering right around 82 or so, so that's not too bad. But if this was a real system, you would want to be hitting your set point within a reasonable time frame, especially for something as simple as just the system we're trying to control. So yeah, that's really about it. I hope you guys got some value out of these videos, and I'm looking forward to having a discussion with you guys on Friday where we'll just be talking about all the different types of process control technologies that are out there, and we'll just be kind of taking a wide, broad look at all those different technologies and how they're used to control different processes and whatnot. So, hope you guys enjoyed.